Okay, so here is the problem. Let's say we have 10 logs represented by these blocks 1, 2, 3, 4, 5, 6, 7 till 10. So actually there are 1 to 1000 logs, but let's make the problem simpler by making taking just these 10 logs and 10 students and see like how the state changes. So I represented open as O and close as C. So let's say student number one goes and open all the logs. Student number two goes and go to only the even number of logs. So see second log he changes, one remains same. So these are the change state for the by the student two, and likewise there are 10 students. So at the end, actually, if you see, um, these are the states, and the only logs open are the first log, fourth log, and the ninth log. So, and these are the perfect square numbers. We'll go in detail like why we are getting the perfect square numbers. But if you see this, the let's say log number 8. So log number 8 changes the state from, okay, the very first time is it's open, so 1, and then 2 from 1 to 2, and then from C to O in 4 and 8. So basically, if you see log number 8, 1, 2, 4, 8 are its factors. So if we change it, the state by even number of times, then ultimately it would be shut, right? Because we say open, shut, open, shut. So if let's say it is even number 4 times, so ultimately the lock would be shut. And the other thing is the lock would be only open if we perform this operation only the odd number of times. So effectively we have to find out the state changes for these numbers. How many factors are there? Like how many? Let's say state some lock number is there. Let's say 9. How many factors would be there? So if you see 9 factors are 1, 3, 9. So how many factors are there? 3 factors. If we say 6, 4, let's say 4. For 4 there are 1, 2, 4. So there are 3 factors. So what it turns out, there's a very important thing is like all the perfect square numbers, like perfect squares are like 1, 4, 9, 25, 36. These are perfect square number, and if we try to calculate their factors, those factors would be always odd. So that's the main gist of this problem, that we have to actually calculate the number of logs which have the odd factors. So what it turns out, so this is for 10. Likewise, if we do it for 20 logs, like then the next number will get 16. And so now we see the pattern 1, 4, 9, 16. So these are the perfect square numbers, and so the answer should be all the numbers between 1, 4, between 1 to 1000, 1, 4, 9, 16, 25, 36, 49, and yeah, likewise. So 100 and till 1000. How many perfect square numbers would be there? So what it turns out, there are 31 perfect square numbers. So answer should be 31. So this is actually straightforward. We are looking for the number of logs which have the odd number of factors, and for that we have only the perfect square number between 1 to 1000.